Hello, everybody, or for anybody who's interested in watching or what have you. So, I am not going to come across or claim to be a machine learning expert or anything of the like. As a matter of fact, I'm going to claim the complete opposite. I just started learning machine learning probably about a month and a half ago or so. I have to be honest. I Machine learning is something that I've kind of postponed or put aside for various reasons. One of the main reasons is, it's been a long, long time since I've had my engineering math and college level math. So, I'm talking about the calculus and the differential equations, the linear and matrix algebra courses that I took in college, the statistics courses. Years and years and years have rolled by since then, because what tends to happen a lot of times is, as you take those courses in college, then you end up in the field of IT and you develop predominantly business and or systems applications, or do a lot of scripting and stuff. And the reality of the matter is, you hardly ever use anything more than, algebra at the most, and a lot of times in the jobs. Now, there's going to be a lot of other cases for other people where they use a lot more than that, but by and large, a lot of the people that I know in the industry, that's pretty much all they've used, especially when you're doing a lot of business applications. So there's been a lot of buzz in machine learning lately, the ability to teach computers to learn and make predictions over certain things based on the volume of data that keeps growing and growing that you accumulate. The long and short of it, that's what machine learning is. I've known about it. And again, because I always had this conception, that you're going to have to be an expert in the calculus, or, dust off your old Diffie-Q books and matrix algebra. And although that may be the case in many situations, if you want to be a data scientist or whatever, my goal is not really to be a data scientist. My goal is to, first and foremost, I'm a computer programmer, full stack developer, doing some stuff in the cloud where I'd like to get into more, doing systems programming, web applications in React, .NET Core, and things of that nature. I'd like to stay in those areas, but I wouldn't mind having a pretty much, I don't want to say basic, but at least enough of a knowledge in machine learning where I could actually talk intelligently as well as work with a data scientist if I had to. Say I was doing a front end or I was writing scripts for them, where they would actually be the ones cranking and churning the data and training the models and going through and cleaning and massaging the data and trying to figure out which features you need for your particular problem. That wouldn't necessarily be something that I would be doing, although I wouldn't mind. It's just that, I'm not tremendously experienced in that area, but it's a good idea to have an understanding of it. So I decided about a month and a half ago or so that heck, I was going to learn this, and not be so intimidated by the fact that you have all this kind of high level math again that you have to revisit and refresh your memory on, especially if you've been away from it for years. And I think for some of the developers out there, you can understand where I'm coming from. But I'm here to tell you, so far so good. In the last month and a half, I've and wanted to share my experiences and try to get you going a little bit if you're interested. Just kind of share my experiences on where I'm at, where I've learned, and what I have learned. Um, all things aside, I've approached my machine learning endeavor pretty much, you know, putting the mathematics algorithms, like how they work, how the algorithms and how the actual mathematical equations work, kind of putting that aside, giving that a backseat, and trying to focus more on number one, what is machine learning? Number two, how can I use it? Number three, um, what is it comprised of? There's many different aspects of machine learning. They talk about algorithms. There's quite a few algorithms. And the key point to remember is there is no one size fits all. And machine learning, as much of a science as it kind of is, it's also an art in the sense that you have to know what data, based on your data sets provided to you, what data is important. What problem are you trying to solve? And based on the problem you're trying to solve, how much historical data do you have? Because again, that's important. In other cases, I guess you could do simulations to generate some data based on, well-known data sets out there in the industry. But you need to go through your data for your given problem. Let's say you're trying to solve a classification problem where you're a credit card company, and based on previous customers' data that you have, which technically the more the better, based on that data, how can you predict future customers as to whether or not they're going to have a good credit rating with you, a bad credit rating, whether they're going to default out on their loans, things of that nature. And the way to do that is to go through your historical data that you've collected and to identify features, which are basically columns. A feature could be a person's name, a location, where they were born. A feature could be how much income they make, so on and so on. So you as a data scientist or whatever have to understand, in order to solve the problem of, is this new customer going to be a good risk or a bad risk? You have to go back through your historical data and identify all of the features that will actually help you make that decision. So there's all kinds of things involved with machine learning. There are also several different types of algorithms for different types of problems. You have classification, which basically is binary for the most part, as well as categorical, which is not just binary, but it's more discrete in the sense that there are 5 known results, based on all of this historical data. There are 5 known results: low risk, high risk, medium risk, moderate risk, and let's just say no risk at all. I'm just making this up off the top of my head. So those would be like the 5 different categories. And you have all kinds of historical data. Now, based on the historical data, you want to see if another quote unquote customer which of those categories he or she is most likely to be. So those are classification problems. And then you have regression problems where there is nothing discrete about it. And there's nothing binary, which is yes or no. For example, in the regression scenarios, you're trying to predict like a stock price for a given day based on previous market conditions, or you're trying to predict in a region house prices based on features like the number of rooms, where they're located, which part of the town they're located, how close the nearest school is, things of that nature. Regression problems tend to give you an actual number, numerous numbers, like almost from 0 to infinity. I know I'm somewhat exaggerating, but basically there is no boundary on regression. And so those kinds of problems, you basically want to, given all this historical data, want to predict the value to it. And then you have clustering, which I'll get into also in like some future videos or whatever. But I wanted to share my experience on, if you're in the same boat as I am, what you can do to get started. And I got to tell you, I did a bit of research, and you can go to YouTube and all that. After going to YouTube and Pluralsight, which I happen to have a subscription to, I kind of did a lot of exploration on Udemy. That's another one of my favorites. And there is a course out there. You don't have to take it. This is just one of the courses that I chose to take. Machine learning, hands-on Python. It's a dirt cheap price if you can get it on days where Udemy has their sales. You don't want to, try to look for the days where you're not paying the full price there. But this given course just is bonkers in terms of the value that you get, and it's phenomenal. So this particular course basically has pretty much teaches you everything about machine learning from A to Z if you've got no experience. And the beautiful thing is they choose to use Python as well as R for all their examples. What does this mean? Um, so if you look at the curriculum or the course content, they go through all of these different steps here, all these different phases, which I can kind of get into a little bit. But every one of these examples, they walk through the problem of when you would want to use something like multiple linear regression. So they walk through these intuition things, which is really cool because it's a lot of background and theory. Then they walk you through a hands-on example. And the hands-on examples, they give you the one example in Python and then the same exact example in R, which is another very popular language, actually developed, I think, in the 90s, but it suits machine learning as well. So every one of these given things here, as you can see, they walk through the problem definition, what is decision tree regression, and then they give you a hands-on lab in Python, and then they give you that same exact lab in R. So what I did is I chose to not do the R stuff. I just went with the Python examples. Maybe at some point in time in the future, I may get back and revisit around and do those same examples in R, but it's quite okay just to do Python and not the R. Of course, the more the better, but to drive the concepts home. But if you can look here, this is a 41-hour on-demand video course. And I don't know about you, but over the years when I've taken courses from Pluralsight, Udemy, and Linux Academy, and some of the others, I would probably say for every hour video course I took, I spent about 3 hours on that 1 hour going through the videos, highlighting things, rehashing, rewinding, and then doing the labs. So, you know, you're going to put in quite a bit of time in this course for the most part if you choose to do it, but it's good quality time. At the end of this course, now I completed this course, I would not consider myself an expert, nor would I actually consider myself qualified to take on a position as somebody doing completely machine learning as a data scientist. No. And I'm admitting that to you right now. There's still a lot more to learn and I need to revisit. But where I am right now is I actually feel pretty confident that I can keep going down further in that path, as well as being able to talk intelligently and participate in meetings and actually write software for data scientists, working close together with them, or be a kind of an assistant to another programmer who is, you know, an expert at the machine learning. So I think this course will get you there. And, you know, of course, think of this as like a college semester course on machine learning. And it'll give you a lot of the basics and it'll walk you through a lot of labs. And it's up to you to take that one step further, but it'll get you a good solid background on the foundations. So definitely a course worth checking out. Another one is Pluralsight. Yeah, I took a course on machine learning SageMaker because I've done some stuff with Amazon, got some certifications, and so there's a course, you know, machine learning SageMaker. Basically, I'm trying to find where that, there we go, right there, deep learning using TensorFlow and Apache MXNet on SageMaker, AWS one. So, you know, this is a decent course if you've got an Amazon background. If you have a Pluralsight subscription, probably want to check into this. The other thing I really like on Pluralsight is machine learning exposed play-by-play. And this one is really good. You know, if you don't have any background at all in machine learning, it's basically a conversation between two really cool people, James Weaver and Catherine Beaumont. I found this course to be very, very interesting. Now, I will admit, Catherine's heavy on the math and James is, you know, more on the development side, but they do break out into some mathematical discussions where they'll talk about Gaussian and, you know, the regression curves, SVM, you know, the vector machine, things of that nature. So parts of it, if you don't have any background, this is a great place to start with this exposed, because they're basically sitting at a desk and having a conversation amongst each other. But there will be some times where they break out into some of the mathematics theory or the neural networks theory. And don't get intimidated if you don't completely understand exactly what they're talking about there. It takes time. I don't completely understand it 100%, but I do understand the concepts of inputs and outputs and epochs, you know, which are rolling iterations where you're training the model, forward propagation, and the concept of backward propagation with error detection and reducing your errors. You know, so they'll go over those kinds of things with you. And again, it takes time to, you know, to digest that. Don't expect to get it on the first try. And they talk about hidden layers. It's an excellent place to start. So I would almost consider starting with this one if you have a Pluralsight subscription. If not, you know, that's okay. If you don't have a Pluralsight subscription, you can just go straight into this machine learning A to Z hands-on Python course, and they go over some major topics of algorithms and stuff. So I'm going to, before I end this video, because I'm going to create some more and I don't want to keep rambling like I always have a tendency to do, to get you started, and I'll probably go further in some other videos, whether they're useful or not, you want to download Anaconda, and you probably want to download the Anaconda Python R distribution. So you can go to the anaconda.com distribution, and you want to download and install, and you might be like, well, that's all fine and dandy, but what is that? So rather than explain to you what it is and bore you like I have been, I'm just going to start it up because I've already gone through the download. It does take time to actually download and install. So as you can see, it's starting up the scripts here. And I'm going to pause this because this will take a little bit of time to start up Anaconda, and I'll resume when that's done. Okay, so Anaconda launched. As you can see, you got the little taskbar icon. When you install it, you get thrown into this thing called Anaconda Navigator. So for those of you who've heard of Jupyter Notebooks, things of that nature, as you can see, Amazon SageMaker actually has a Jupyter Notebook service that you can launch up Jupyter. But Anaconda, think of it as kind of like, if you're doing Android apps, it's kind of like Android Studio. If you're doing Visual Studio for C# or .NET or whatever, think of it kind of like that, but more so you get your own environments. I don't claim to know a lot of it. You know, you can basically install RStudio here if you want to do development in R, but basically this is kind of like a one-stop shop portal for machine learning, data science, things of that nature if you want to try. Spider is one of the most important things, especially if you're going to take this course, or any course for the most part, in machine learning here. And again, I can't recommend this course enough, and in some future videos I'm actually going to be, without giving away too much of the content and stuff like that, because I don't want to get in trouble or violate any copyright stuff. I've tried to reach out to the authors to see if I can share some of their examples. I've not yet heard from them. You know, I'm going to be kind of careful in what I share because I want you to buy this course. It's dirt cheap. I mean, it's a no-brainer. It costs, when you get it on sale, it's the cost of a dinner. I mean, and the amount of hours and knowledge and stuff it gives you, it's just a no-brainer to go out there and buy this course. But anyways, for this given course, they use Anaconda, and Anaconda seems to be a very popular, shall we say, environment. So Spider is the main thing here. So if you launch Spider, this takes just a little bit of time, but Spider gives you a complete Python interactive development, which some of my future examples is going to show you. And let's just let this launch up. Again, you've got your Jupyter Notebook. If you want to do R development, which I haven't done, you can install that. As you can see, it's launching Spider. Why did I choose Python over R? Eventually, someday, if I ever get more and more into machine learning, it's not a necessary requirement for me, but if I ever get more into it and I start taking on more of a role in that area, um, yes, I'll probably end up doing, learning more about R. But as a developer and stuff, Python is a very, very good language for machine learning. Um, Stephen Greider, another well-known expert in React and things of that nature, he has a machine learning course with another twist to it, which I've got, and it's called Machine Learning in JavaScript, which is really cool too. If you don't want to learn Python, you can do a lot of your machine learning applications in JavaScript. So I highly recommend that course. And anyone who's taken Greider courses knows how good he is there. So there's all kinds of different angles. So 1 second here. So when you're thrown into Spider, basically, I downloaded the course and stuff like that. We'll go through just a real simple example of what Spider gives you in that sense. So going through some of the labs and whatever, doing basically a simple linear regression issue. What you can do here is you get this interactive Python terminal on the right-hand side down here. You get this super cool thing called Variable Explorer, File Explorer, and I'm not going to begin to explain any of this stuff here, but what you can do basically is, you see how I highlighted that little section there? If you hit Control-Enter, watch what happens on the right side. It actually executes those given statements right there. And if you go into Variable Explorer, all of a sudden, lo and behold, you see variables there. As you can see, I'm creating a data set variable object in Python. And if you click on it, it shows you exactly what's in that data set. As you can see, I'm also splitting values out of that data set into columns, my X columns, which is basically your independent variables, and then your Y, which is your dependent variable, the result that you're trying to get. This is supposed to be like historical data. And of course, your X1, which is your independent variable. And then we can apply linear regression on it right here. So you highlight that section and keep your eyes open to the bottom right-hand corner here. It's actually executing the linear regression algorithm on that set. And whoops, I've got let's see here. I think I forgot to do that. Okay, I'm skipping around. There we go. I just forgot to highlight that section. So I executed this and then re-executed that there. You can see it executed all of that. I'm incrementally doing that. Now if you look at your Variable Explorer, because you basically are doing a split right there based on your X and your Y's into your training and your test set, which I explain it in a future video or whatever. Now you can see we've got our test set right there for our independent variables, and our result for our dependent variables on the test set, and then our training for the independent variable, that's our X, and then our training for the dependent variable, which is our Y. So as you can see, all of this is happening inside of Anaconda. It's a full-scale Python execution environment, so you're actually executing Python real time. And then what else is really cool is based on after you create your model and fit it, you can see I'm actually using the plotting library right here so Anaconda actually out of the box will install a lot of the machine learning libraries that you're going to be needing, including like the PyPlot as well as Panda, which allow you to do things like fitting your models, actually reading your spreadsheets and things of that nature. For all the different kinds of machine learning algorithms, you get the sklearn, which Anaconda will help install for you out of the box. Also, how cool is this? You can see we're plotting based on our results and our predictions, so you can actually visualize what you've just created with your module. So that's what Spider gives you, which is a full-blown Python Python environment before doing your machine learning stuff. Whereas RStudio with an Anaconda does the same thing, but only it's for the R programming language. So I hope this helped. I know it didn't go into too much detail, but great place to start. Download Anaconda, download Spider, and if you've got money, if you really want to learn this stuff, or at least get a fairly decent introduction to this stuff, where you start feeling confident to take on more and more stuff going forward. Um, I can't recommend this course enough. I'm sure there's other courses out there that may work for you, but this is one that worked quite well for me. So thanks for watching, and hope to see you again in another video or what have you. So take care and bye bye.